So basically, the order of the matrix switches. Okay, the order goes from being, if this here started off as a 2x3 matrix, the transposition would be a 3x2. Okay, and this little T symbol here, that T means transpose. Okay, so if you ever see a T up where like an exponent would be, that's saying you're going to take a transposition instead. Okay? Any questions on how that works? Pretty straightforward, right? Alright, good. Give you a second to copy that down. And then we're going to look at the, I will let you guys go get lunch a little early. We'll look at the last two kind of subjects for the day, and these are just special matrices that pop up time and time again. Okay? Everyone got these down? Alright, good. Okay. Alright. The last three things that there was on that list, matrix multiplication, finding the determinant, finding the inverse matrix, we're going to save those for next week because they're a little bit more involved. But one thing I will go over right now are two special matrices that pop up. The first one my first special matrix is the zero matrix. Okay? And it's typically written as an O, which is just basically 0. This is a matrix where every element is a 0. Okay, so an example, okay, my 0 matrix could be something like a 0, 0, 0, 0, 0, 0. This is a 2x3 0 matrix.
How would you determine the order?
Huh?
Would the order be given to you?
Yeah, the order would be given to you. It would say like a 2x3 0 matrix, or a 3x4 0 matrix, or a 5x2 0 matrix. Okay. Usually two. It's sort of because every element's a goose egg. You know, it doesn't really matter if I'm using a 0 matrix in a problem. Okay, I would just say, okay, if I saw that 0, I would say, all right, whatever rules for order would just apply to that matrix. Yeah. So if I'm saying like adding, if matrix A was 2x5, I'm adding the 0 matrix to it, the result would be 2x5. Yeah. Okay. Any questions there? All right, good. All right. The next special matrix that we've got, okay, is the identity matrix. Okay. Now, an identity matrix only exists for square matrices. Okay. Matrices where the order is square, like 2x2, 3x3, 4x4, etc. Okay, so only exists for square, that is n by n matrices. Okay, and what it is, it's a matrix whose diagonal, okay, is populated with 1s and every other element is a 0. Okay. So, an example of that, what I mean by that, the 2x2 identity matrix would be 1, 0, 0, 1. Okay. The 3x3 identity matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. The 4x4 identity matrix would be 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1, etc. Okay, and as we're going to see on Monday, the deal with the identity matrix is when we do matrix multiplication, if I multiply a matrix by the correct identity matrix, the result, the matrix, nothing happens, basically. It just gives me the same answer I started with. Okay? Everyone got that? That's basically what it's for. But that's what identity matrix means. And this is also what I mean by the diagonal. Notice how there's ones going down a line like this, but then everything else is a 0. Okay? Huh? Nope. If they go the other way, it's no longer the identity matrix. It's something different. Okay? The other, yeah. Any questions there? All right. In that case, y'all have good afternoon. I will see you all on Monday if I don't run into you earlier. And, get to lunch.
Yeah.